Hi, I'm Jim with Proto Design Labs, and I'm going to take you through the installation of our new N4 accessory decoder. Before us, we have a Kato N-scale number 4 turnout, and that's what it's made for. And let's turn it over and get started. So we've got 5 screws to remove, and use a Phillips head screwdriver for that. And then we'll remove the cover. Just want to walk through some of the components that you see. There's a plastic actuator here, and it has magnets on both ends. And in conjunction with this coil, it either attracts or repels, depending on which direction the current's flowing through the coil. One end, like the end with the gap, will attract. The end where there is no gap between the magnet and the coil core will repel, and so you get some push-pull action. There's also a heat coupler, and inside that heat coupler, as you'll see as we get further into it, is a thermal switch. The thermal switch is intended to switch the current off in the event that you're using an electrical switch that is not momentary, because the coil would otherwise get hot. We won't be using the thermal switch because our processor, once we activate the coil, the processor will continually turn the coil off. In fact, that's one of the things it just does as long as the decoder is on. So there's never an opportunity for the coil to get warm. There's a tie bar down here. When the actuator moves back and forth, that left and right motion translates into up and down motion to move the point rails back and forth between themselves and the stock rails. So we're going to leave that in a down position. And then there's that translation of motion between the actuator and the tie bar is accomplished by, let me move it one more time, the straight spring here. So there's some spring action, even if the turnout is not set for the direction you're coming from the frog side. The point rails can be shoved aside by the flanges of the wheels of the train. We're going to take the actuator out first. Pick it up with some electronic tweezers. Give it a twist where it meets this T-shaped switch. That does some power routing. We won't be using that. And then we've got to remove hex nuts. These hex nuts attach the board to the actual rails. Those are that's how our board's going to pick up power and pass it along to the frog rails. So that power is going to be delivered continuously. And that's one of the reasons why we won't be using the switch. We also make better contact than what the switch is able to accomplish. I tell you, the hardest part of this is just working with small screws and nuts and washers. Okay, so now we also have some Phillips head screws. There's 4 of them. We'll remove those as well. 3 of these are part of the power routing selections that you can make in the stock switch. We're going to reuse just one of those pan head screws. Okay, I think there's one more pan head screw here, yeah. At this point, we've removed enough hardware to be able to lift the Kato board out of place. Okay, place it right here. And you'd think we removed all the hardware, but there's still 3 nuts in the bottom of the road bed. So we'll take those out. And those are not going to be replaced. Okay, so those 3 nuts are gone. Going back to this assembly, there's a thermocoupler that we've talked about a few times. We're going to remove that. That doesn't get reused. And then we have the thermal switch, the coil, and a Proto board. And so the next step is going to be to separate these items. Okay, so we've removed the Proto board along with the thermal switch and the coil, and now we need to separate these pieces. So we're going to hold, perhaps this is a good view for you. We're going to try to hold it up and heat each of these 3 pads and use the soldering iron to kind of push the wires away from the pad. Once we get one away, the others come out a little bit easier. Let's see. Oh, it's disconnected. Okay, so we're there. But now what we also need to do is to unwrap the coil wire from one of the leads of the thermal switch. We do as much as we can because the coil lead is soldered to the thermal switch, and we push the remaining part off by heating the thermal switch wire and just wiping the soldering iron tip down to slide the wire off, the coil wire off. So now that that's off, we're going to take the coil wires and straighten them out because they're just easier to work with that way. And once we get the coil in place, after it's soldered, we're gonna tuck them back so they'll be folded up again. So I just kind of let my nail run down along it. I see it's got a little silvery tip. I see the other lead has a little bit of silvery color on it, and that's what we want because that makes it more solderable. Okay. So now we're going to install the new N4L board in place in the roadbed. And just to give you a little tour of the board, it's the same size and shape and hole pattern as the Proto board that it replaces. And it uses existing attach points for power, so that's where the 4-threaded studs come in. There are 2 pins that are used for address setting. They have a shorting jumper in place that comes with the N4L board. Those will remain in place for when you want to reprogram the board address, the accessory address, and then you remove them and it retains the address. There are 2 solder pads, and these are going to be used to attach the coil. So this is the only soldering that has to be done. And so that you understand what we've done in terms of product, we have the red board, which is for right-hand turnouts. So we purposely made it red. Hopefully, as you remember, that's for the right-hand turnouts, and the green board is for left-hand turnouts. Okay, so we're going to reuse some of the hardware. We're going to reuse one of the pan head screws, and here it is. What it's doing is it holds the frog in place. And then we take you do that first because if the board or the turnout shakes, sometimes the washers want to jump off the studs, the threaded studs. So it's just to kind of keep things buttoned up a little bit. Now the next part of this is to get the nuts in place. The nuts are not so easy to get started sometimes just because they're small, that's all. No problem, you'll get them going. You can try to get them started, or you can try to take a nut driver and just put it over top and see if you get lucky. And I think I got lucky. The thing you don't want to do is to have the nuts, screwing the nuts tight while the nut is at an angle. Because if there's any resistance at all, you should stop and reset the nut. But this is not a big job. If it weren't for all the screws and nuts, it would be done. Okay, we've got that done. So this is what, well, we feel this is lives up to the term we use, drop-in replacement. With reference to the wire coming from the glue spot, hold it with your tweezers. And I've got the board flipped around, but just take note that the wire is going to the solder pad at the top of the board. That would have been at the top of the board if I hadn't rotated it around. Melt it and hold it. Okay, now the other free wire. We're going to do the same thing. Heat the solder pad with heat the solder on the solder pad. Dip the wire into it. Hold it while it solidifies. And that's all the soldering we're going to need to do. Okay, so we're going to rotate the turnout around again to how we had it in the beginning, and then we're going to orient the coil so that it works, so that the current goes through the coil and the coil is oriented in the right direction so that we get the correct movement out of the turnout. So we locate the coil with those features in the road bed that we talked about before. And then you can just kind of fold the wires and tuck them in. What you don't want them to do is to hang outside the area where the cover is going to seat, because you don't want the cover pinching on the wires. But that's actually pretty good, what I have here. Okay, now there's a step that is going to ensure that we solder the wires correctly to the coil, and that's just to take a meter, a multimeter. Here's the multimeter we're going to use. Okay, very inexpensive multimeter. It's about $40 from Amazon. And what we're going to do is attach the probes of the meter after we turn it on and put it on a resistance range. We're going to attach the probes of the meter to the two solder blobs and see if we get some continuity with the coil. So now we're on a resistance range, and we're going to contact, and we get 20.4 ohms. That's exactly what we're looking for. So we've got a good connection. We've got to do a few items that I would call plastic surgery. We've got to cut the actuator extension that used to control the power routing switch. So if you can see what I'm doing here, I'm using a flush cutter. It's slid up against the plastic that encases the magnet or surrounds the magnet, and we just cut and it flies, and we've got a good cut. There's not much to cut there. So the actuator is ready. And the only other part we have to do is we have to cut a little bit away from the cover. We have our address pins that are going to that would interfere with this projection from the cover. All right, so picking up where we left off, we got to put the actuator in place. So sometimes you want to hold the coil because the ends would be attracted by the magnets in the actuator and may cause it to jump out of place. And we've got to get the spring right in the middle of the tie bar. Okay. And we move the actuator back and forth, and we see that the tie bar seems to be moving correctly. So at this point, we're satisfied with the assembly, and we're going to put the cover back on. And we're done. I think that looks clean and finished, and I think we live up to the name Made to Fit once again. So the only thing that's left to do is to test it. We'll get a piece of test track out, connect it to a command station, and see how it works. Okay, so the last step of the installation should be to test the turnout and make sure that it works. And not only that, but make sure that it moves in the direction that you want. And so we're going to use a Digitrax DCS52. We're going to put it in switch mode, at which point you should see for the soft keys, the A soft key says thrown, the B soft key says closed. So right now the turnout is in a position thrown. It's favoring the curved route. So let's put it in a closed position, or at least attempt to. And it moves in the correct direction. And then let's hit the thrown key to move it back to the curved path. So curved path, straight path, curved path, straight path. It's exactly what we want. Now, if it happens to move in the opposite direction of your expectation, there's a configuration variable. It's 516. And if you set that to 255, it will reverse the commands that are sent over the DCC link, and that'll fix that problem. You also have the option of unsoldering the wires and reversing them, which I didn't think was a really good idea. And you have the third option, which is to take the coil and flip it end for end, and that would also change the polarity relative to the command station. So we showed you how to use the turnout and check its function, and now we're going to show you how to change the accessory address. So flip the turnout over, install the jumper that's supplied with it. So we're going to just put it in, and that connects those two pins of the turnout. And now any accessory decoder address that you throw at it within its range from 1 to 2044, the turnout will respond to. So let's take a look at that. It's responding to address 1. I'm going to change it to 2044, the top of the range. Throw, close, throw, close. Now, once you remove the jumper, it will retain the last address that you sent to it. So 2044 as an address continues to work. And if we switch to 1, we get no functionality. And that would be the same for any address except for 2044. So that's how you change the address. We think it's simple and convenient. And again, I hope you like it. Thanks. Bye.